Hello, class. Welcome to our next math lesson for 8th grade Eureka Math. We're still working in Module 4. We're on Lesson 4, so 4-4. It's called Solving a Linear Equation. So you'll need pages 29 through 39 in your workbooks. Rip those out to get a page for notes so that you can take notes with me today. Maybe 2 pages, because my notes took 2 pages today because there's a lot of vocabulary. Either 2 loose pages or 2 pages in your math notebook, but maybe some colors so that you can label things. But get your tools ready and let's begin about solving a linear equation. So we've been talking in Module 4 about linear equations. You've been writing linear equations. And in Lesson 3, you were telling me if linear equations were true for a certain value of x. I gave you an equation, I told you what x could be, and you told me if x was true. Today, I'm going to give you an equation, and you have to tell me what x is. So I just give you the equation, and you tell me what x is. To find x, you need to use some properties to combine and move around all the terms to find what x is. To isolate x, to find x, you need to use some properties. So today we're going to have a few vocabulary words. I think there's 9 on my list, I believe. 9 vocabulary terms in this lesson. So it's going to be a heavy vocabulary, but most of them are properties that you use to solve equations. And it's very important that you know what these properties are, you know how to use them, you know how to work with them, manipulate them in order to find x. Excuse me. So you have to use all of these properties to find x. And you have to be able to tell me what property to use and when. So you're going to decide what property to use, when to use it, in order to find what x must be. So let's start talking about the vocabulary. Now, because there's a lot of vocabulary, I'm going to talk about them probably faster than it takes you to write them down. So feel free to pause this video at any time to write down the vocabulary terms. So pause the video whenever you need to finish writing your definitions, because writing these definitions is important. When you write them down, it helps your brain remember them better. So please take the time to write these down and pause the video if you have to catch up. So here's the vocabulary. First word is term. A term we've seen before is part of an expression. It could be a constant like 3 or 13 or 45. It could be a variable like x, y, or z. It could be a combination of a number and a constant and a variable like 3x is a term. A term is just part of an expression. In today's activities, we're going to combine terms, move terms around to find x. So we're going to see a lot of terms today. To find x, we need to use the properties of equality. Now, properties of equality, you see on the paper, are rules that keep expressions equal if all expressions are changed the same way. So these are rules that keep expressions equal as long as all the expressions in an equation are changed the same way. And there's 4 types of properties of equality. There's the addition property of equality, addition POE, the subtraction property of equality, the multiplication property of equality, and the division property of equality. There's 4 of them. So the addition property of equality says that if A equals B, then A plus C equals B plus C. They are still equal because all I did, I added C to both sides. You can add C to both sides and the equation stays equal. If the equation starts equal, adding the same thing to both sides keeps it equal. Subtraction property of equality is kind of the same thing, except for that if we start equal, then taking the same thing away from both sides keeps it equal. So if A equals B, then A minus C equals B minus C. Taking the same thing away from both sides keeps things equal. The multiplication property of equality is the same concept, just with multiplication. If A equals B, if we start equal, then A times C equals B times C. Multiplying the same thing on both sides keeps it equal. Multiplying the same thing on both sides keeps equality. Now, it's very important that now you'll notice that both sides have to change the same way. Adding C, subtracting C, multiplying C. It's always the same. So as long as we keep things the same on both sides, it stays equal. It even works for division with the division property of equality. If we start equal, then dividing both sides by the same thing keeps it equal. Keeps equality if we divide by both sides. The only exception to this, C cannot equal 0. It is impossible to divide by 0. So this is true for everything except if C equals 0, because it's impossible to divide by 0. But those are the properties of equality: the addition one, the subtraction one, multiplication, and division. If we change both sides the same way, we keep equality. If both sides change the same way, we keep equality. So those are the first 4 properties we're going to use in this lesson. Now might be a good time to pause the video and finish copying any definitions into your notes, because I'm going to scroll up to see the other 3 properties we're going to use today. So these are the 3 other properties: the commutative property, the associative property, and the distributive property. And you've probably seen these before in 5th, 6th, and 7th grades. But we're going to review them today, and we're going to use them today. So the commutative property says, I like to remember it like commute. Commutative property is like commute. Commute is when you go to work, when you travel to work, when you move around. So commutative property is moving numbers around. The commutative property says that when you add or multiply, terms can be combined in any order, which means I can move the terms around. Like right here in this example I gave you, A plus B plus C equals A plus C plus B. I just moved the B and the C, and that's okay, because if everything is adding or if everything is multiplying, you can move numbers around. Sometimes this makes things easier. Sometimes this makes it into mental math. For example, if you have 9 plus 7 plus 1, it would be easier if you did 9 plus 1 plus 7, because 9 plus 1 is 10. That's easier than doing 9 plus 7 first. So the math gets easier if you move numbers around. The commutative property tells you it's okay to move those numbers around if everything is adding or if everything is multiplying. The next property is the associative property. The associative property, like associations, like the National Basketball Association or the American Medical Association. The NBA is an association, is a group of basketball teams. The AMA, the American Medical Association, is a group of doctors. So the associative property is all about groups. And it says when that you are adding or multiplying, terms can be grouped in any way, which means you can put the parentheses wherever you want with the associative property. Like in this example, you can do the A plus B first and put that in parentheses. Or if it's easier, you can do the B plus C first. You can do whatever you want. So for example, if it says this, 7 plus 9 plus 1, the associative property says, well, everything is adding, so how about I move the parentheses and do the 9 plus 1 first, because that will be easier. So the associative property also helps us move things around, move the parentheses around, so we can choose what we want to do first. But remember, it only works if everything is adding or if everything is multiplying. Our last vocabulary word for the day is the distributive property. The distributive property is the third big property that we're going to talk about with commutative, associative, and distributive. Now, distributive, I like to remember distribution or to distribute. Like Amazon has distribution centers, or if someone's a good passer in basketball or soccer, they say that they distribute the ball well. Distribute means to pass, to sort, to organize, to pass it in. So the distributive property means when you means that multiplying a sum is the same as multiplying both parts and then adding them. Really what it means, let me show you, because if the problem is set up like this, the distributive property, remember, passing tells us the A is passed to the B and the A gets passed to the C. So we do A times B plus A times C. The A gets passed in to both parts in the parentheses. That's the distributive property. The A is passed in to everything inside the parentheses. It gets passed to everything inside the parentheses. You can also do the distributive property in reverse. If you have something like AB plus AC, you can pass the A out of both of them to get this to go in reverse. So if you have a problem set up like this, the A is passed in to everything on the inside. If you have something set up like this, you can pull the A out and put it on the outside. So the distributive property is about passing in or pulling out. And those are all the properties we're going to be learning about. We have the commutative, the associative, the distributive. We have the addition, subtraction, multiplication, division, properties of equalities. I know it's a lot of words. It's a lot of ideas. You should be familiar with some of them. Hopefully they all make sense. We're going to use them today. But if you need to right now, go back, watch this part again, make sure you fully understand the definitions of these terms, and also make sure you've written down everything. So if you need to pause the video, go back and copy any definitions, or if you need to hear my explanations again, pause the video right now and get that done, because I'm going to move on and I'm going to start showing you some examples of what we're going to be doing today. So if you need more help with the vocabulary, take it or by pausing the video. Or if you don't need any more time, let's look at some of the examples of what we're going to be doing today. So today, we will use the different properties, all 7 of the properties that we defined in our notes, to find true solutions of linear equations. We're going to use all those properties, all 7 of them, to find true solutions of linear equations. And so here's a couple examples of what we're going to do. Excuse me again, let me drink some water. Much better. Okay, so using different properties to find true solutions. Like in example A right here. Example A starts with 2x minus 3 equals 4x. That's the equation we're starting with. So you'll see I have my work on one side and I have my properties on this side. I tell you what I do. So this is the work. This is my explanation. This is what I do. This is why I do it. This is how you are going to organize your work today. I want to see the steps you take, and I want to see the explanations. So I started with 2x minus 3 equals 4x. And then I said, well, I can use the subtraction property of equality because remember, my goal is to find x. So I want x by itself. Right now I have an x on this expression and an x in this expression. I only want x on one side. So I have to move all the x's to one side. Well, the way I do that is with the subtraction property of equality. Remember, it tells me I can subtract. If I subtract the same thing from both sides, it stays equal. So I'm going to take 2x away from both sides. If I do it to both sides, I keep equal. After I do 2x minus 2x, I get 0 on this side, and I get 2x on this side. That's what happens when I subtract. Subtract again, 0 minus 3 is negative 3. Now I have negative 3 equals 2x. I'm closer, but still, I only want to know what x is. I want x all by itself. So to make the 2 go away, I have to use the division property of equality. Because I need to do 2x divided by 2. 2x divided by 2 is just x. Because 2 divided by 2 is 1. That gives me x. But the division property of equality says if I divide by 2 over here, I have to divide by 2 over here. Remember, to stay equal, I do the same thing to both sides. So I do 2x divided by 2 to get 1x. And then I do negative 3 divided by 2 to get negative 3 over 2, negative 3 halves. And I can just stop there. That's my solution. X equals negative 3 over 2. I use the subtraction property of equality. And I use the division property of equality to solve it. I have a true solution. Another example, let's look at example B for another example. This time I'm starting with 3/5 x minus 21 equals 15. 3/5 x minus 21 equals 15. That's my equation. So I need to think, I want to get x all by itself. That is my goal. Well, luckily, there's no x on this side, so x is already on this side. But there's numbers with the x. There's a 3/5, there's a minus 21. I want to get those things out of there because I just want x. So the first thing I do is I kind of start far away from the x. I'm not going to do the 3/5 first. I'm going to fix the minus 21 first. When you're solving equations, your first step is always to get the x term by itself. So 3/5 x is the term with the x. I want to get that by itself first. So I work far away from the x. This time I have minus 21. Well, I need to do plus 21 to make that go away, because minus 21 plus 21 turns into 0. But the addition property of equality tells me if I do plus 21 on this side, I have to do plus 21 on that side. I want it to stay equal, so I use the addition property of equality and do the plus 21 on both sides. So after I add 21 to both sides, I get the 3/5. This turns into 0, so I only have 3/5 x. And then 15 plus 21 is 36. So I'm getting closer to getting x by itself. There's still this 3/5 that I need to get rid of. Well, that's 3/5 x. How do I get rid of 3/5 times x? Well, I multiply by the reciprocal, because 5/3 times 3/5 cancels out. Because 5 in the numerator and 5 in the denominator cancel. 3 in the numerator, 3 in the denominator cancel. So this just 3/5 times 5/3, because they're reciprocals, just make 1. 5/3 times 3/5 makes 1x. So I multiply 5/3 to get 1x. But the multiplication property of equality tells me that if I multiply this expression times 5/3, to stay equal, I need to multiply this expression by 5/3. So I do 36 times 5/3 also. So 5/3 times 3/5 x gives me 1x. I have to multiply some fractions a little bit here. 36 times 5/3. Multiplying fractions, I combine my two, 36 times 5 divided by 3. I know 36 is 3 times 12. So I break 36 into 3 times 12. And then I have a 3 in the numerator, a 3 in denominator. That turns into 1. So it cancels the denominator and cancels the 3 in the numerator. So I just keep 12 times 5. 12 times 5, so I get x equals 12 times 5 after I pull the 3 out, pull the 3 and keep 3 out. So that is 60. 12 times 5 is 60. That is the true solution. So I use all my properties plus multiplying fractions. If you need help multiplying fractions like this, make sure you contact me and I will show you how to multiply fractions. But it's something you've been doing since 5th grade, so you should remember. But if you need a little refresher, if you need a little reminder, please schedule a meeting with me. I'll give you a reminder about how to multiply fractions because you will have to do that today. But that is how we do this. That is how we get x all by itself to find the true solution. We use our properties. That's a couple examples. Let's do a couple exercises together. You can see them as I go. That is the end of our notes. If you did not have enough time to copy down any notes, you can pause the video right now, go back, and copy down anything you missed. But I'm going to keep on moving. I'm going to open to page 29 for some of the exercises that we're going to be doing. So I think we have, let's see, on page 29 and 30, we have 5 exercises that we're going to do together today. So follow along with me. Go to page 29, exercise 1. Solve the linear equation. This is our equation, x plus 2 plus x plus 4 plus x plus 6 equals negative 28. State the property that justifies your first step and why you chose it. Okay, so it wants us to, remember, I'm going to do my work on one side and my explanation on the other. So first, let's copy the equation. X plus 2 plus x plus 4 plus x plus 6 equals negative 28. The first thing I'm going to use the commutative property. And the reason I want to use the commutative property is remember, commutative property in your notes means I can move things around. Everything is adding, so I'm allowed to move things around. I'm just going to move them all around so I get all the x's next to each other and all the constants next to each other. So I have 1, 2, 3, 4 x's, so I want the x's all lined up. And I want my numbers all lined up because that is organized, easier for me to read, easier for me to solve. Now, what I'm going to do with this, I'm just going to add. X plus x plus x plus x is 4x. I have 4 x's. Plus 2 plus 4 plus 6. Now, this is where you could add with, if it were me, I would do add and I would use the associative property. Because I would want to do this part first, because that will make the math easier. 4 plus 6 is 10. 10 plus 2 is 12. So I get 4x plus 12 equals negative 28. So now it's much simpler. I took the long equation and made it simpler. Now, what I'm going to do now is I'm going to say, okay, well, I really just want x by itself. So I need to get rid of the 4 and get rid of the 12. And remember, we always want to work away from the x term first. So we want to work on the 12 first because that's away from the x term. It makes it so much simpler if you work away from the x term first. So for this, I have plus 12. Well, to turn that into a 0, I'm going to do minus 12. And that turns into 0. But I need to use the subtraction property of equality to keep it equal. If I do minus 12 on this side, I have to do minus 12 on that side also. To stay equal, that's the subtraction property of equality. So after I do the subtraction property of equality, 4x plus this 0 is just 4x. If I have negative 28 and negative 12 together, that's negative 40. Now I'm getting closer to my true solution. I still have this 4 to deal with. Now this is 4x, that's 4 times x. To make it go away, I divide by 4. Because 4 divided by 4 is 1, and 1x is just x. So I divide by 4 to get 1x, and that's x by itself. But remember, I need to do the division property of equality. To stay equal, I have to do the same thing to both sides. I have to divide by 4 on both sides to stay equal. So negative 40 divided by 4 is negative 10. That is my true solution, which I probably should have written in blue. So let me write over it just to stay consistent. So x equals negative 10 is our true solution. We're done. This is what we did, and these are the properties. These are the reasons why we did everything. By the way, if you feel comfortable doing this, feel free to work ahead. Make sure I want to see both columns. Do not just give me answers. I need to see your work, and I need to see your explanations. You are allowed to work ahead and check your work with mine when you're done. Or you can just keep working with me. I'm okay with that too. But let's move on to exercise 2. It says solve the linear equation 2 times 3x plus 2 times the quantity 3x plus 2 equals 2x minus 1 plus x. State the property. Okay, so let's work on this. First thing I'm going to do is I'm going to copy the equation it gives me, paying attention and making sure I copy it precisely. And now I'm going to think about what to do. Well, first thing I'm going to do, I'm going to actually use the distributive property first. Because what I want to do is I want to pass remember, distributive property is about passing. I want to pass the 2 to everything in the parentheses to make it simpler. So 2 times 3x is 6x. That's 2 times 3. And then I have to pass it to the 2 also, so 2 times 2 is 4. So that's what I got right now. So this side looks pretty simplified. This side right here, I'm going to use the commutative property because I want to get the x's next to each other. I'm going to, remember, commutative property is all about moving things. So I'm going to move this x over here. So I'm going to do 6x plus 4, that side stays the same, 2x plus x minus 1. That's the commutative property. Now I'm going to add the 2x plus x, so I get 6x plus 4 equals 3x minus 1. I combine the 2x plus x to make 3x. Now, everything's combined. It's shorter. Now, I combined all my terms. Now I need to think about moving the x to one side and all the numbers to the other side. So to do this, I'm saying, okay, well, I have 6x on this side and 3x on this side. I need to take them away from one side, and in my mind, doing minus 3x is easier than doing minus 6x. So I'm going to do 3x minus 3x to get 0. So I get 0 minus 1. But remember, I need to use the subtraction property of equality. Because if I do minus 3x on this side, I have to do minus 3x on that side. I need it to stay equal, so I need the same change to happen to both sides. So 6x minus 3x is 3x. So now I have 3x plus 4 equals 0 minus 1, which is 3x plus 4 equals negative 1. So I just subtracted right here. This step was subtract, 0 minus 1. Now, I moved the x over. I still need to move the 3 and the 4 away. And remember, we always start with the term far away from the x term. So we're going to do the 4 first. Well, to make the 4 go away, I do minus 4 because that makes 0. But the subtraction property of equality tells me I have to do minus 4 on this side also to stay equal. That's the property of equality. Now 3x plus 4 minus 4, that makes 0, so I just get 3x equals. Now I have negative 1 and negative 4 together, which is negative 5. There we go. We're getting closer. Now I'm ready to make the 3 go away. Well, this is 3 times x. I really just want 1x, so I need to divide by 3 because 3 divided by 3 is 1. That gives me 1x. But I need to follow the division property of equality. And if I divide by 3 on this side, I have to divide by 3 on that side also. To make it work, I have to divide by the same thing on both sides. So negative 5 divided by 3 is just negative 5/3. That is all you need to write. That is our true solution. That is what x equals. All the work I did on this side, all the reasons why I did it there. I hope it all made sense. I hope you understand every step I took and why I did it. This is how you could work when you really understand the properties. When you really understand the properties, a lot of this turns just into mental math and it goes faster. But today I want you to prove that you understand the properties by showing me all your steps, please. Let's move on to another exercise. Page 30 has exercise 3. Here we go. Solve the linear equation x minus 9 equals 3/5 x. State the property that justifies your first step and why you chose it. So it's the same thing. I'm going to start with writing the equation. X minus 9 equals 3/5 x. Now here's where it gets a little bit tricky because you can have a couple choices right here. I'm going to tell you right here. Well, x is over here, x is over here. We only want x's on one side. But what side should we move them to? Well, my question is, what's going to be easier? Find the easier math. If we move this x over here, we need to do minus x over here and minus 1x. If we move this over here, we do minus 3/5 x to both. We either do minus 1x to both sides or minus 3/5 x to both sides. I don't know about you, but if I look at this and say, well, 3/5 minus 1x, I'm going to get a negative number. I try to avoid negatives when I can. So I think it's going to be easier, and this is my opinion, you can disagree, if we do minus 3/5 x to both sides. That will stop us from getting negative numbers. We're going to use, this is also the subtraction property of equality because we're taking something away, we're taking the same thing away from both sides to keep equality. Now, 3/5 x minus 3/5 x just gives us 0. So this side turns into 0. But now we have to do 1x minus 3/5 x. Well, 1x, remember, if we do 1 minus 3/5, 1 is just going to be 5/5. Because 1x is the same as 5/5 x, because 5 divided by 5 is 1. So instead of writing 1x, I'm sorry, I was covering it up. Instead of writing 1x, I'm going to write 5/5 x. It's the same thing. 5 divided by 5 makes 1, but because I put 5/5, I can do 5/5 minus 3/5 super easy. So 1 minus 3/5 is hard, but 5/5 minus 3/5 just gives me 2/5 x. So now I have 2/5 x minus 9 equals 0. Now, I did that to get rid of my negative numbers. Some people might just do the minus 1x on both sides. I did it this way. You can do it whatever way you want. But now I still want to get x by itself. So let's move. I need to move the 2/5. I need to move the 9. Remember, we always start with the term farthest from the x term. So let's do the minus 9 first. How do I get rid of minus 9? I do plus 9, because minus 9 plus 9 makes a 0. But I need to follow the addition property of equality, and I need to do plus 9 to that side also. I need to do plus 9 to both sides. Now I have 2/5 x equals 9. And everything's positive because of what I did first. Because I moved it over here and made this side 0, I get positive numbers. I like working with positives better. I still need to get the x by itself. Well, this is 2/5 times x. So I really, really want just 1x. Well, how do I turn a 2/5 into a 1? I multiply by the reciprocal. I multiply by 5/2. Because this cancels. 5 times 2 is 10. 2 times 5 is 10. 10 on top of 10 is 1. Or you can just say 5 and 5 turn into 1. 2 and 2 turn into 1. So that's how I get 1x. But I need to follow the multiplication property of equality. If I did times 5/2 on this side, I have to do times 5/2 on that side. I have to do it. And then multiplying fractions, I just go straight. This 9 is really a 9/1. Multiply straight across. 9 times 5 is 45. 1 times 2 is 2. 45/2. You can stop there. You do not need to turn it into a mixed number. That is our true solution. So this one was a little bit tricky. It looked a little bit tricky, but really it was only 3 steps. Subtraction property of equality, addition property of equality, multiplication property of equality gives us the true solution. Once you know your properties really well, these problems get super easy. Your job is just to learn the properties, to practice using them, which is what today's lesson is all about. You're just practicing the properties. So make sure you reach out to me for help if you need it today. Let's go to exercise 4, another equation. Solve this equation and give your reasons. So let's work on it. We have, I'm going to copy my equation, 29 minus 3x equals 5x plus 5. Good enough. Now, I need to move things around. I need to find out what x is going to be. So in this equation, I'm looking at this and you know what? I have minus 3x. I want to kind of get rid of that. I'm just going to move. This bothers me. The minus 3x just bothers me. You could do whatever order you want. You could do the minus 5x to both sides, but me, personally, my choice would be add 3x. because minus 3x plus 3x makes a 0. Then I get rid of the subtraction. But I need to follow the addition property of equality, because I do plus 3x on this side, I have to do plus 3x on that side also. That's the addition property of equality. So I get 29, and then this turns into a plus 0, so I get 29 equals 5x plus 3x is 8x plus 5. Now it's better, but I want to get this. I want x all by itself. So how do I get rid of the 8 and the 5? I start with the 5, because remember, I always start with the term that is not the x term. I do the x term last. So let's do, how do I get rid of the plus 5? I just do minus 5, because plus 5 minus 5 makes 0, but I have to follow the subtraction property of equality, because if I do minus 5 on this side, to stay equal, I have to do minus 5 on that side also. I need it to stay equal, so I follow the property and change both sides the same. 29 minus 5 is 24, and then I have 8x, and this turns into 0, so I just get 8x. But remember, I want to get x all by itself. Now I have 8 times x. I really just want 1 times x. So how do I turn 8 into a 1? I do 8 divided by 8. That makes a 1. But I need to follow the division property of equality. If I divide this side by 8, to stay equal, I need to do that side divided by 8. And 24 divided by 8 is 3. So x equals 3. That is our true solution. I'm going to pretend I did not try to write the t first and turn into a u. So once again, 3 steps. The addition property of equality, the subtraction property of equality, the division property of equality to give you the true solution. And once you know the properties really well, this gets easier. So use today to practice. Let's work on number 5. Last exercise we're going to do together. Solve this linear equation. Show your justification. So let me copy it. 1/3 x minus 5 plus 171 equals x. Okay, so the first thing, what do we want to do first? Well, the first thing that I'm going to do, I'm going to actually combine my like terms. I'm going to combine. I'm going to add this first. Now, this says minus 5 plus 171. What I'm going to do, I'm sorry, I'm going to use the associative property first. And the associative property, remember, lets me make a group. So what I'm going to do, I'm actually going to change this minus 5 to plus a negative 5. That's important because it needs to be to use the associative property, I need everything to be adding. And minus 5 and plus a negative 5 mean the same thing. I'm going to use the associative property, and I'm going to do, because the associative property lets me do whatever I want to first, I'm going to do this piece first. The negative 5 plus 171, because I want to combine those first. So I'm going to get 1/3 x plus, now again, I want to remind you this is what I did. I saw that it was minus 5, so I changed it to plus negative 5. You are allowed to do that. You just need to remember what it is. The reason I did that is because I wanted to use the associative property, but it keeps the same thing. So negative 5 plus 171 is the same as 166. Let me do that math for you over here on the side. I had -5 plus 171 in case anybody has problems. This is what I'm doing. I'm going to use the commutative property right here, and I'm going to do the 171, and I'm going to move it like that, 171 plus -5, which is, remember, just the opposite of what I did before. That's just 171 minus 5, which is 166. That's how I did it. If you ever have a negative plus a positive, just use the commutative property to move them around. It makes it much easier to do. If you have a negative plus a positive, you can just change it to a subtraction sentence by using the commutative property. Anyway, that's what we did right there. Now this looks simpler, but I have an x on both sides. I only want x on one side. So what's easier to do? Is it going to be easier to do -1, take 1/3 x away from this side, or take 1x away from this side? Well, my brain is telling me, well, if I do -1, some people might say just do the -x. The problem with that is then I get a negative number, and I want to kind of avoid negative numbers if I can. So instead of doing -1x and getting a negative, I'm going to do -1/3 x on this side. 1/3 x minus 1/3 x is a 0. But I need to follow the subtraction property of equality, which tells me I need to do -1/3 x on this side also. So this side, 1/3 x minus 1/3 x is 0, so I just get 166 on this side. Now I need to do this subtraction. This is 1x minus 1/3 x. Well, remember for exercise 3, how about if I just change this 1x to 3/3 x? Because 3/3 is the same as 1. 3 divided by 3 is 1. So instead of doing 1x, I can just do 3/3 x. It stays the same value. It's still 1x, it's just written a different way. The reason I write it this way is it makes the subtraction easier. Because 1 minus 1/3 might be tough, but 3/3 minus 1/3 is just 2/3 x. Makes it somewhat easier. Makes it easier if you change the 1x to 3/3 x. But the x is still not all by itself, and I really want the x to be alone. This is 2/3 times x. So to make it go away, I need to, remember, multiply by the reciprocal. Multiply by 3/2, because the 3 and the 3 cancel, the 2 and the 2 cancel, and that just gives me x by itself. But I need to use the multiplication property of equality, because if I multiply this side by 3/2, I have to multiply this side times 3/2. I have to multiply the other side by 3/2. So now we need to multiply some fractions to find out what x is, because I have 1x over here after I multiply these together. I still need to find this. So I'm going to simplify. Simplify before I multiply my fractions. There's a 2 right here. Well, 166 is an even number. So I know that it's 2 times something because it's even. It's actually 2 times 83. 83 times 2 makes 166. So it's even. I can know that. So now this 2 cancels with this 2. So now I just get 3 times 83 equals x. So now I just need to do 3 times 83, which is 249 equals x. 249 equals x. That's my true solution. So in today's work, you can see that you need to know your properties pretty well to know what step to do. you need to pay attention and make sure you change both sides the same way. Change both sides. So there's three. You need to know your properties. You need to pay attention to make sure that these both sides stay equal, and you change them the same way. You can also see today you're going to need to know how to work with fractions, adding and subtracting fractions, as well as multiplying fractions. You're going to need to know some of that stuff. If you need any help with any of these, remember that I am here for you. I am ready to help you. You just need to reach out to me and ask. I will help you on anything you need. Even if you need a little bit of a reminder about how to work with fractions, I can help you with that. But let's look at the rest of the lesson. Here's the lesson summary. Just giving you a reminder about some of the properties we learned. The exit ticket, we'll talk on page 33. We'll talk about that last. They give you a homework helper on page 35 and 36. Oh, and 37, 3 pages of homework helper. So if you need more help, look at page 35, 36, and 37. They give you the steps and they tell you why they did the first thing. So use the homework helper on page 35, use the example they give you on page 36, and use the one they give you on 37. It'll help you. When you feel you're ready to try it all on your own, the problem set is on page 39. There are 7 questions on the problem set. Now, they did not give you enough room to work on these, so you'll probably have to do your work on a separate piece of paper. Remember, I want to see your work, and I want to see the list of properties you used. I want to see both. I want your work to look just like the work we did together. Look just like that, please. So there's 7 questions. You're solving the equations for all of them, using the properties, using your math skills, making sure that you keep things equal to find true solutions, to find what x is. Remember, my answers to the problem set are all online. You go to the Google Classroom, you can see my answers to the problem set, so you can check your work. Not so you can copy my answers, but so that you can check your work. After you finish checking your work and you feel good about this lesson, and you feel like you know how to do the properties, then you can go back to the exit ticket on page 33, and there are 3 questions on today's exit ticket where you are going to try to find true solutions. Check, and you're going to try to see if you are correct. Take a picture of this page 33, take a picture of this exit ticket, turn this in on the Google Classroom so that I know you know what you're doing. That's your work. That's what you have to turn in today, a picture of this exit ticket after you try the problem set and check your answers with mine. If you get into any trouble, if you have any obstacles while you're working today, remember that I'm here. You can reach out, send me an email. We can have a private meeting, and I can give you a little bit of reminders about how to do things. I can even show you how to do some of the questions in the problem set. You just have to ask. But if you understand everything, if you've been paying attention, you should be able to start well. Have fun, do your best, and I will see you for lesson 5 on another day.